I'm Derek Warner,
And I'm Erica Young.
and this is our video assignment. We're going to start with the hack spectrophotometer. So, we're going to start with doing apparent color, 120 color, and the wavelength will be 455. So, what we're going to do is rinse the cuvettes, triple rinse. We're going to fill one cuvette to the 10 milliliter line with unfiltered deionized water. And one with our sample water. So we're going to select that on the hack spectrophotometer. So first we're going to take the distilled water, and we're going to zero up the unit. And then we're going to take the sample and do a reading. So it came up under range. So we're going to take these cuvettes, empty out their contents, rinse, put them away. Wiping, and we're done.
Okay, now we're using the colorimeter and I'm doing iron. So I go to 51 iron and click enter. Then rinse out. Then fill it up to the 10 milliliter line. And insert it, close the lid, and scan blank. And that's done. the same sample, I add 0.5 milliliters of iron reagent number 1. And now cap and mix. And then I'm using a spoon to add 0.1 grams of iron reagent number 2 powder. And now cap and shake for 30 seconds. Okay, and now wait 3 minutes for the color to develop.
We'll come back in 3 minutes.
Okay, so now after 3 minutes, it's changed color a little bit. So we don't mix it.
You should wipe it.
Okay, wipe it off. Close the lid and scan sample. And it's 0.82. And the value is in PTCO, platinum cobalt color units. So now take that out. Putting the waste in the proper thing. And then rinse that off. And then put it back in the proper place. And we're done.
Alright, so now we're doing conductivity. First they're going to check that all the cords are on right, and check the unit, make sure nothing's broken, functioning properly. And then I'm going to go ahead and turn it on. So we're going to ensure it's in microsiemens. And then we're going to change it, the mode, to make sure that we have proper compensation for the temperature, because the conductivity will change with temperature. So we want the proper conductivity for what the temperature is going to be. So we're going to take the probe, rinse it with distilled. Take it and put it in our sample bottle. Make sure to bob the probe. So the reading I'm getting is 503 microsiemens at 20.3 degrees Celsius. Take this probe out of the water with the sample and rinse it with distilled. And that's all.
Okay, so now I'm doing pH. And the battery power is okay. And we don't have to put in the probe, it's already in there. And And then I cleared the previous standards. Now I'm going to calibrate it. Okay, so first I'm using a 4. Okay, and allow 2 minutes for the test to stabilize. And then I'm going to push hold to confirm the calibration. And then rinse off. Okay, now 7. And then wait for 2 minutes. And then click hold. There we go. Rinse it off again. And now 10, the last one. And wait 2 minutes. And then click hold. And then we're done the calibration. Then we're going to test our sample. First I'm going to mix it, and then I'll let it still. Okay, so the pH is 10.07 and the temperature is 20.0 degrees Celsius. Shit, how do you take it off that? Still on hold? Okay, never mind. It's 7.19 and the temperature is still 20.0 degrees Celsius. And then clean off the probe. And then put it back in its proper place.
We also got another sample here with also an air in the top. So first we need to properly preserve our sample. So with that, we're going to add 8 drops of manganese sulfide. And 8 drops of the alkaline potassium iodized azide. cap this. Mix it by inverting. A precipitate forms. So then we're going to take the 1 gram spoon and add 1 gram of sulfuric acid powder. So now we've got to shake this and then let everything settle. So we'll let that settle and come back. So now we're going to do our titration by putting our preserved sample into our titrator bottle. To the 20 milliliter line. Cap it. This is our direct reading titrator. So we're going to fill it with sodium thiosulfate. And we're going to try and get this sample to a faint yellow color. So while slightly shaking the bottle. So now we've got it to like a faint yellow color. We're going to remove the titrator and cap. We're going to add 8 drops of starch indicator solution. Sample should be turning blue, as it is. We're going to replace the cap, and the titrator. Then we're going to titrate until the sample turns clear again. So we're at the end of our titrate, so we're going to have to refill. Continue to titrate. So there, it's back to clear. The reading on the plunger is 1, so plus 10 from our last, and we're at 11. So that would equal 0.22 parts per million. And then we're going to put this waste into the waste chemical and rinse. And that's everything. So we're gonna, this is the DO meter, we're gonna check that everything's working, cables are good, machine's good, turn it on. Pull it out, make sure there's no air bubbles, it's clean. So we're going to stick it in this water sample that we did the titration with, so it's a known milligrams per liter. So we're getting 9.33. The temperature is 21 degrees. We're going to rinse our probe.